These are NCERT exercise questions from the lesson Chemical Kinetics. From the rate expression for the following reactions, determine their order of reaction and dimensions of rate constant. 3NO gives N2O. Rate is equal to K into concentration of NO raised to 2. So first let us find out the order. Order is sum of the powers of the concentration terms in the rate law expression. Here rate is given as rate is equal to K into concentration of NO raised to 2. Here the power is 2, so order is equal to 2. Now let us find out the unit of K. K is equal to rate by concentration of NO raised to 2. Unit of rate is equal to mole per liter, mole liter raised to minus 1, second raised to minus 1, and concentration unit is mole per liter raised to 2. So we can cancel 1 mole per liter. When we take this to the numerator, it will become mole raised to minus 1 liter second raised to minus 1. Second question, rate is given as rate is equal to K into concentration of H2O2 into concentration of I minus. So order is equal to sum of the powers of the concentration terms. So order is equal to concentration of H2O2 is 1 and I minus also 1. So 1 plus 1, it will be equal to 2. Now unit of K is equal to rate by concentration of H2O2 raised to 1 into concentration of I minus raised to 1. Unit of rate mole liter raised to minus 1 second raised to minus 1 and concentration unit mole per liter, that is mole liter raised to minus 1 the whole square. We can cancel 1 mole per liter, so we will get mole raised to minus 1 liter second raised to minus 1. Now the third question, rate is given as rate is equal to K into concentration of CH3CHO the whole raised to 3 by 2. Here order is 3 by 2 because the sum of the power, only one concentration term, so its power is 3 by 2, so order is 3 by 2, and unit of K, that is equal to rate by concentration of CH3CHO the whole raised to 3 by 2, and unit of rate is equal to mole liter raised to minus 1 second raised to minus 1 and denominator mole liter raised to minus 1 raised to 3 by 2. Now let us take the power 3 by 2 to the numerator. So mole liter raised to minus 1 raised to 1 minus 3 by 2 second raised to minus 1. 1 minus 3 by 2 is minus 1 by 2. So we will get mole raised to minus 1 by 2. Liter raised to minus 1 into minus 1 by 2 will be plus 1 by 2 second raised to minus 1. So mole raised to minus 1 by 2, liter raised to 1 by 2 and second raised to minus. Next, rate is equal to K into concentration of C2H5Cl. So order is equal to sum of the powers, here only one term, so order is equal to 1. Now unit of K is equal to rate by concentration of C2H5Cl. Unit of rate is equal to mole liter raised to minus 1 second raised to minus 1 and unit of concentration, that is mole per liter. So mole per liter and mole per liter got cancelled. So our unit is second raised to minus 1. The reaction 2A plus B gives A to B. Rate is equal to K into concentration of A into concentration of B square, where K is equal to 2 into 10 raised to minus 6 into 10 raised to minus 1 into 2 into 10 raised to minus 6 into 10 raised to minus 1 into 2 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 into 10 raised to minus 1 into mole raised to minus 2 liter square second raised to minus 1. Calculate the initial rate of the reaction when the concentration of A is equal to 0.1 mole per liter and concentration of B is equal to 0.2 mole per liter. Calculate the rate of reaction after concentration of A is reduced to 0.06. So first let us find out the initial rate. Initial rate is equal to K into concentration of A into concentration of B raised to 2. K is given as 2 into 10 raised to minus 6 and concentration of A is given as 0.1. So I can write 1 into 10 raised to minus 1 into concentration of B is given as 0.2. So 2 into 10 raised to minus 1 the whole square. That is equal to 2 square is 4, 4 into 2, 8, 8 into 10 raised to minus 6 into minus 1 into minus 2, that is equal to 8 into 10 raised to minus 9 mole liter raised to minus 1 second raised to minus 1. So this is the initial rate. Then when initial concentration of A was it is reduced to 0.06 from 0.1 to 0.06. So concentration of A reacted or consumed, that is equal to 0.1 minus finally 0.06, that is equal to 0.04. So according to the equation we know 2 moles of A reacts, that time you can see 1 mole of B reacted. When 2 moles of A reacted, 1 mole of B reacted. So here the amount of A reacted is equal to 0.04 mole per liter. So concentration of B reacted will be its half according to the equation. They are in the ratio 2 is to 1. So half of concentration of A reacted. So that is equal to half into 0.04, that is equal to 0.02 mole per liter. Now we got the amount of B reacted, so we can calculate final concentration of B. Initial concentration of B was 0.2 and amount of B reacted is 0.02. So balance the remaining concentration is 0.18 from the initial 0.02 reacted. So final concentration is 0.18 mole per liter. Now we got the final concentration of B as well as A is given in the question. So we can find out the final rate. So rate is equal to K is constant 2 into 10 raised to minus 6 into concentration of final concentration of A is 0.06 and final concentration of B is 0.18 the whole square. So when we simplify this, we will get 3.89 into 10 raised to minus 9 mole liter raised to minus 1 second raised to minus 1. The decomposition of ammonia on the platinum surface is zero order reaction. What are the rates of production of nitrogen and hydrogen if K is equal to 2.5 into 10 raised to minus 4 mole liter raised to minus 1 second raised to minus 1. So let us write the decomposition equation. 2NH3 gives N2 plus 3H2. Rate is equal to minus 1 by 2 dNH3 concentration of NH3 by dt, that is equal to plus dN2 by concentration of N2 by dt is equal to plus 1 by 3 into d concentration of H2 by dt. So for zero order reaction, we know rate and rate constants are equal. So we can write rate is equal to rate constant for a zero order reaction. Now let us find out rate of production of N2. Rate of production of N2, so we can equate dN2 by dt is equal to K. Here K value is given as 2.5 into 10 raised to minus 4 mole raised to minus 1 liter second raised to minus 1. Rate of production of N2. Now rate of production of H2. Rate of production of H2. Here 1 by 3 dH2 by dt is given as K. So rate of production of H2 means dH2 by dt. D concentration of H2 by dt is equal to 3K. That is 3 into 2.5 into 10 raised to minus 4. So that is equal to 7.5 into 10 raised to minus 4 mole raised to minus 1 liter second raised to minus 1. So this is the rate of production of hydrogen. Decomposition of dimethyl ether leads to the formation of methane, hydrogen and carbon monoxide, and the reaction rate is given by rate is equal to K into concentration of CH3O CH3 raised to 3 by 2. The rate of the reaction is followed by increase in pressure in a closed vessel. So the rate can also be expressed in terms of partial pressure of dimethyl ether, that is rate is equal to K into partial pressure of CH3O CH3 raised to 3 by 2. If the pressure is measured in bar and time in minute, then what are the units of rate and rate constant? So unit of rate instead of concentration, here concentration we are expressing in bar. So bar minute raised to minus 1. Unit of rate is equal to rate by partial pressure of, from the rate law expression we can write rate is equal to K into partial pressure of CH3O CH3 raised to 3 by 2. So K is equal to rate by partial pressure of CH3O CH3 raised to 3 by 2. And unit of rate bar minute raised to minus 1 and pressure unit bar raised to 3 by 2. So 1 minus 3 by 2 will be minus 1 by 2. So bar raised to minus 1 by 2, minute raised to minus 1. A reaction is second order with respect to reactant. How is the rate of the reaction affected if the concentration of the reactant is doubled and reduced to half? So reaction is second order. So we can write rate is equal to K into concentration of R raised to 2. First case, concentration of the reactant is doubled. Then when R becomes 2R, rate is equal to K into concentration of 2R the whole square, that is 4K into concentration of R square. That is rate becomes 4 times of initial rate. Second case, when R becomes R by 2, rate is equal to K into R by 2 the whole square. So that is equal to 1 by 4 KR square. That is, it becomes, rate becomes 1 by 4 times. Rate become 1 by 4 times of initial rate, or rate decreased by 4 times. The effect of temperature on the rate constant of reaction. How can this temperature effect on the rate constant be represented quantitatively? It has been found that for a chemical reaction with a rise in temperature by 10 degrees, the rate constant is nearly doubled. This can be explained by Arrhenius equation K is equal to A e raised to minus Ea by RT, where Ea is the energy of activation and A is the frequency factor. In a pseudo first order reaction in water, the following results were obtained. Calculate the average rate of the reaction between the time interval 30 to 60 seconds. So, average rate is equal to minus C2 minus C1 by T2 minus T1. That is equal to minus 0.17 minus 0.31 divided by 60 minus 30. So that is equal to 0.14 by 30. So when we simplify, we will get 4.67 into 10 raised to minus 3 mole liter raised to minus 1 second raised to minus 1. And second part, we have to calculate the rate constant, calculate the pseudo first order rate constant for the hydrolysis of ester. So pseudo first order rate constant we have to calculate for each time interval. So let us take first 0 to 30, then we can take 0 to 60, then we can take 0 to 90. So K is equal to 2.303 by T, time is 30 seconds, log initial by final 0.55 by 0.31. So when we simplify this, we will get 1.91 into 10 raised to minus 2 second inverse. Next time interval between 0 to 60. So K is equal to 2.303 by 60 log 0.55 by 0.17. So when we simplify, we will get 1.96 into 10 raised to minus 2 second inverse. And the third case, K is equal to 2.303 by 90 log 0.55 divided by 0.085. So when we simplify, we will get 2.07 into 10 raised to minus 2 second inverse. Therefore, average of K, that is equal to 1.91 plus 1.96 plus 2.07. In all this case, 10 raised to minus 2 is common, by 3 into 10 raised to minus 2. So when we simplify, we will get 1.98 into 10 raised to minus 2 second inverse. A reaction is first order in A and second order in B. So let us write the equation. Rate equal to K into concentration of A raised to 1 into B raised to 2. Now we have to write the differential rate equation. So minus dr by dt is equal to K into concentration of A raised to 1 into B raised to 2. How is the rate affected on increasing the concentration of B 3 times? So when B equal to 3B, minus dr by dt is equal to K into concentration of A into concentration of 3B square, that is equal to 9K concentration of AB square. That is, rate becomes 9 times of initial rate. 9 times of initial rate. Next case, What happens to the rate when concentration of A and B both doubled? So minus dr by dt is equal to, instead of A we can write 2A, and instead of B we can write 2B because both are doubled. So 2 into 2 square, 4 into 2, 8, 8 square. Rate becomes 8 times of initial rate. 8 times of initial rate. Reaction between A and B, the initial rate of reaction was measured for different initial concentrations of A and B as given below. What is the order of the reaction with respect to A and B? So let us write the general rate law expression. Rate equal to K into concentration of A raised to X into concentration of B raised to Y. 5.07 into 10 raised to minus 5 is equal to K into 0.20 raised to X into 0.30 raised to Y. Let it be equation 1. Similarly, 5.07 into 10 raised to minus 5 is equal to K into 0.20 raised to X into 0.10 raised to Y. Let it be equation 2. And third one, 1.43 into 10 raised to minus 4 is equal to K into 0.40 raised to X into 0.05 raised to Y. Equation 3. Now equation 1 by equation 2. Left hand side, when we divide we will get 1. K and K cancel. 0.20 raised to X cancel. 0.30 by 0.10 we will get 3 raised to Y. So we can write 3 raised to 0 is equal to 3 raised to Y. Therefore Y is equal to 0. Now similarly equation 3 by equation 2. 1.43 into 10 raised to minus 4 divided by 5.07 into 10 raised to minus 5 equal to K and K cancel, and Y term is 0. Any quantity raised to 0 is equal to 1. So we will get 2 raised to X. 1.43 divided by 5.07, when we divide you will get 2.821, that is equal to 2 raised to X. Take logarithm on both sides. Log 2.821 equal to X log 2. Therefore X equal to log 2.821 divided by log 2. So we have to divide the logarithmic values, then we will get approximately as 1.496, that we can take it as 1.5. So order with respect to A is equal to 1.5 and order with respect to B is equal to 0.